Vanos is BMW's answer to variable valve timing. It is a combined hydraulic and mechanical camshaft control mechanism, managed by the car's DME engine management system. At the lower end of the engine speed scale, the intake valves are opened later, which improves idling quality and smoothness. At moderate engine speeds, the intake valves open much earlier, which boosts torque and permits exhaust gas recirculation inside the combustion chambers, reducing fuel consumption and exhaust emissions. Finally, at high engine speeds, intake valve opening is once again delayed, so that full power can be developed. Vanos operates on the intake camshaft in accordance with engine speed and accelerator pedal position. Vanos significantly enhances emission management, increases output and torque, and offer better fuel economy. The latest version of Vanos is double Vanos, used, among others, in the new M3. The Vanos system is based on an adjustment mechanism that can modify the position of the intake camshaft versus the crankshaft. Double Vanos adds an adjustment of the intake and exhaust camshafts. Vanos was first introduced in 1993 on the BMW M45 engine used in the 5 Series. In overhead cam engines, the cams are connected to the crankshaft by either a belt or chain and gears. In BMW Vanos motors there is a chain and sprockets. The crankshaft drives a sprocket on the exhaust cam, and the exhaust cam sprocket is bolted to the exhaust cam. A second set of teeth moves a second chain that goes across to the intake cam. The big sprocket on the intake cam has a big hole in the middle. Inside the hole is a helical set of teeth. On the end of the cam is a gear that is also helical on the outside. There is a little cup of metal with helical teeth to match the cam on the inside and to match the sprocket on the outside. The V for variable in Vanos is due to the helical nature of the teeth. The gear is moved by a hydraulic mechanism that works on oil pressure controlled by the DME. At idle, the cam timing is retarded. Just off idle, the DME energizes a solenoid which allows oil pressure to move the gear to advance the cam 12.8 degrees at mid-range, and then at about 5,000 revolutions per minute, it allows it to come back to the original position. The greater advance causes better cylinder fill at middle RPM for better torque. The noise sometimes heard is the result of tolerances that make the sprocket wiggle a bit as the cup gear is moved in or out. Double Vanos or double variable camshaft control significantly improves torque since valve timing on both the intake and outlet camshafts are adjusted to the power required from the engine as a function of gas pedal position and engine speed. The exhaust valve control also serves the function of the EGR valve and reintroduces exhaust as needed. On most BMW engines that use a single Vanos, the timing of the intake cam is only changed at 2 distinct RPM points, while on the double Vanos system, the timing of the intake and exhaust cams are continuously variable throughout all of the RPM range. With double Vanos, the opening period of the intake valves are extended by 12 degrees with an increase in valve lift by 0.9 mm. Double Vanos requires very high oil pressure in order to adjust the camshafts very quickly and accurately, ensuring better torque at low engine speeds and better power at high speeds. With the amount of unburnt residual gases being reduced, engine idle is improved. Special engine management control maps for the warm-up phase help the catalytic converter reach operating temperature sooner. Double Vanos improves low RPM power, flattens the torque curve, and widens the power band for a given set of camshafts. The advantage of double Vanos is that the system controls the flow of hot exhaust gases into the intake manifold individually for all operating conditions. This is referred to as EGR or exhaust gas recirculation, allowing very fine amounts of exhaust gas reintroduced into the engine. While the engine is warming up, Vanos improves the fuel air mixture and helps to quickly warm up the catalytic converter to its normal operating temperature. When the engine is idling, The system keeps idle speeds smooth and consistent thanks to the reduction of exhaust gas recirculation to a minimum. Under part load, exhaust gas recirculation is increased to a much higher level, allowing the engine to run on a wider opening angle of the throttle butterfly in the interest of greater fuel economy. Under full load, the system switches back to a low recirculation volume, providing the cylinders with as much oxygen as possible. Vanos and Valvetronic are BMW's high-tech answer to keeping emissions in check and delivering high performance at the same time.